3.3. Solving quadratic equations using square roots. Now here's the thing, folks. We know how to solve already. We know how to solve quadratic equations. The two bits in our toolkits are factoring. Okay, that's when we get an equation. It's some quadratic equal to 0, and we can factor it. That's if the discriminant is greater than 0 and a perfect square. That's how we can tell. Or we can just look at it and we can factor it. And we know how to using the quadratic equation, or sorry, quadratic formula, which is x equal negative b plus or minus the square root of b squared minus 4ac over 2a, just once. There we go. This is always going to work. Always, no matter what. Factoring will not always work. There aren't always quadratics that we can factor. We are going to focus on today a third option by using square roots. So we know how to solve by factoring. We know how to solve by using the quadratic formula. Now let's learn a third way. And this way can always be used as well. So you can solve a quadratic equation in the form ax squared plus bx plus c equals 0, where b equals 0, okay, when this form right here equals 0, by isolating the square term and take the square root of both sides. The square root of a positive real number can be positive or negative, so there are two possible solutions in this equation. Because we are given so many options, we must always check for extraneous roots. So that means that roots that don't make sense. Okay, so if you get a square root of a negative number, not a negative hashtag, but a negative number, or when we're verifying, we get different answers. So this would be -3, and say this one would be 5, okay? That means that if the verification is not the same on either side, it means either we've done something wrong with our algebra, or the roots are extraneous. So solve for the variable in each of the following equations. This one's kind of easy. Okay, this kind of reminds me of Pythagorean theorem, a squared plus b squared equals c squared, because the last step, what we need to do is we need to take the square root. Here's where grade 11 pre-calculus comes in. If I were to square root both sides, I'm going to say x equals positive or -3. Okay, it could be either plus or minus. Why? Because if I verify, which I need to do for every single one, so verify. And so this is for x equals +3. My left hand, oh no, this is left hand side. This is right hand side. The left hand side is x squared, but I'm going to put in my x equals +3, 3 squared. That equals 9. And my right hand side always equals 9. I'm just going to highlight, use my highlighting tools here. This is my right hand side, and this is my left hand side of the equation. But what happens when I put in, when I want to verify x equals -3? Okay, left hand side, right hand side. I'm going to grab these colors. I'm going to say my left-hand side of the original equation is x squared. My right-hand side of the original equation is 9. If I were to put in -3 squared, I would get -3. This reminds me of grade 9 times -3, because that is the base, because it's held in brackets. Negative times a negative is positive. 3 times 3 is 9, so that equals 9. So left-hand side equals right-hand side. So we indeed have two answers. So whenever you're square rooting both sides, remember we need to consider both the positive and the negative answer. about this next one? So what I want to do is I want to isolate the variable. I'll just use a different color. I want to get this guy all by his lonesome. Okay, so I'm going to add 1 to both sides. So 2x squared equals 6. I'm going to divide both sides by 2. X squared equals 3. I'm going to take the square root of both sides. X equals, plus or minus the square root of 3. And because we're in pre-calculus, we don't mind getting an answer that looks like that. Don't turn it into a decimal, because this right here, the square root of 3, holds an infinite amount of precision. Whereas if you were to simply round some numbers, it won't give you that precision. So I'm going to verify. Left-hand side, right-hand side, and I have 2 to verify, so I'm just going to do this. Left-hand side, right-hand side. I hope that I'm showing you guys kind of like quick ways to give your fullest answer. So, boop, 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 boop. So what I'm going to do is I'm going to say, I'm not shine from my highlighter. I'm going to write in right away 2x squared minus 1 and 5. 2x squared minus 1 and 5. Okay, because left-hand side and right-hand side are the original equation. So I'm going to try in x equals positive root 3, because positives are easiest. So I have 2 times root 3 squared minus 1. Root 3 times root 3 is simply 3. So I have 2 times 3 minus 1. 6 minus 1, 5. Check and check. Woot woot. That's great. Let's check the left-hand side here and of the equation when we assume that x is negative root 3. So 2 negative root 3 squared minus 1. So I'm just going to step this one out a little bit more. 2 negative root 3 times negative root 3 minus 1. Negative times a negative is positive. Root 3 times root 3 is 3. So 2 times 3 minus 1. 6 minus 1, 5. Left-hand side equals right-hand side. Woot woot. C. So this is already in a beautiful squared factored form, really. So what I'm going to do is I'm going to take the square root of both sides. So then I get x minus 4 equals, because the square root of x minus 4, x minus 4 squared is x minus 4. And this one I'm still going to get the positive and negative of root 12. So that means that if I have a positive and a negative, that means that there are 2 solutions. Kind of like in our quadratic formula. Remember when there's the plus minus? So I'm going to isolate my x. So x equals 4 plus or minus the square root of 12. So you might be thinking, oh my goodness, I really don't want to verify this, but we're going to. Left-hand side, right-hand side, left-hand side, right-hand side. And the reason why I'm doing 2 of these is because we have 2 values of x to verify. And the first one is going to be x minus 4 squared. The the right-hand side is going to be 12. So we have x minus 4, same here, squared, and then we have 12. So I'm going to substitute my 2 x values. So I have x equaling 4 minus the square root of 12, and I have 4 plus the square root of 12. So in for my x, I'm going to put the 4 minus the square root of 12. So 4 minus the square root of 12. What I'm going to do is I'm just going to highlight that in yellow so you know what's what. Or where I'm getting it from. I'm going to say minus 4 squared. 4 minus 4. Oh, we lucked out, folks. Negative root 12 squared. And that is simply going to be 12. Okay, left-hand side equals right-hand side. We are good. So now I'm going to take this, and I'm going to say, instead of x, I'm going to write in 4 plus square root of 12. So I'm going to say 4 plus root 12 minus 4 squared. I'm going to highlight that in green, what is the same. I'm just substituting. So I have 4, I'm just going to simplify what's in the brackets, 4 minus 4, so we're just left with root 12 squared, which is simply 12. Left-hand side equals right-hand side. Woot woot! That's great.